All right, so we're going to start looking at quadrilaterals. Before we were looking at polygons, which could be any shape. Now we're specifically going to start looking at quadrilaterals. One thing we need to remember about quadrilaterals, they have two properties. Properties of quadrilaterals are that they have to have four sides. That's the quad. That's what that stands for. So if they have four sides, what we just learned is that their interior angles equal 360 degrees. All right, so they have four sides, their interior angles add up to 360. That's a quadrilateral. Today, we're specifically going to be looking at parallelograms. Parallelograms. All right, so once you have that written, let's turn to the inside. And we're going to look at properties of our parallelograms. So a parallelogram has all the properties of a quadrilateral. That means that, remember, it has four sides and the interior angles add up to 360 degrees. So properties specific to your parallelograms are numbers 2 through 6. What we're looking at are both pairs of opposite sides are going to be parallel. So that means that this side is parallel to this side, and then the top is parallel to the bottom. So that big parallelogram to the right will go over. Top is parallel to bottom, and left is parallel to right. So looking at our properties, we see that opposite sides are congruent. So opposite sides of parallelograms are going to be congruent. That means that this side is congruent to this side, and the top is congruent to the bottom. So if they're parallel, then that means for a parallelogram that they're congruent. So if we draw our congruency marks, top is congruent to bottom, left is congruent to right. If opposite sides are congruent, then that means that opposite angles are congruent. So when we draw our congruency marks, I'm going to use arcs. Those two opposite angles are congruent. These two opposite angles are congruent. So if you can see the whole thing, we'll say this angle is congruent to this angle. And then the other two opposite angles are congruent. Diagonals are going to bisect each other. Remember, bisect means to cut in half. So first, let's draw our diagonals as straight as we can. So if they bisect, no matter what it might look like, if they're bisecting, it means they're cutting in half. So those two halves are equal to each other. These two halves are equal to each other. So if we draw it on the big one, here's one diagonal, two diagonals, so this one's congruent to that one, this one's congruent to that one. One more, then we'll do the examples. So we've talked about diagonals, angles, sides. Let's go back to talking about those interior angles. So if they're consecutive, which means they're next to each other, they have to be side by side, then they are supplementary. So what we mean by consecutive, if you were to label them like 1, 2, 3, 4, you would have to go in order, all right? You could start anywhere. It means if they're side by side, so 1 and 2 are supplementary, 2 and 3 supplementary, 3 and 4 are supplementary, 1 and 4 are supplementary. Those are consecutive. And remember, supplementary means 180 degrees. So let's look at our two angles, or our two examples at the bottom. Our two examples on the bottom, it says if ABCD is a parallelogram, find each missing measure. So if it wants to know about AB, we're looking at that side. Remember, opposite sides are congruent. So if CD is 9, then AD, or AB is 9. Then it's looking at AC. So here's the diagonal. Well, remember, diagonals bisect each other. So if this one's 11, then this one is 11. And I'm going to put 9 right there. So AC, sorry, it wants the whole thing, right? So 11 plus 11 is going to be 22. Then it wants BE. If we're looking, we're going to look for, right here is BE. So once again, diagonals are bisected. If this one's 7, then that means that that one is 7. So then it wants the measure of angle BAD. So it's going to want that angle right there. So what we need to remember is that these are parallel. Your diagonals make a transversal. Then we have alternate interior angles. So this one up here we see is 49. That means that this one is 49 degrees. So then you can say 27 plus 49 is equal to 76 degrees. That's the whole angle. Then it wants to know what's the measure of angle ADC. So now we're looking at this angle right here, ADC. Well, remember, this angle right here is supplementary to this one. So 49 plus 27 gives you 76. So then we're doing 180 minus 76 is going to tell us that this angle is 104 degrees. Our last one is ABD. So now we're looking at that angle. Remember, this whole side adds up to 104. With our alternate interior, then this one is 43. So we would say 104 minus 43 makes this one 61 degrees. Alternate interior, they're coming back. Parallel lines cut by a transversal. If PQRS is a parallelogram, find the measure of angle PSR. So let me highlight that just so we see. PSR, that's the angle that they're wanting. Well, if we look at what they gave us consecutive angles. So that means they're equal to 180 degrees. So if we do 7x plus 4x, because we're going to be adding them, we get 11x, and then negative 13 plus a negative 5 gives us negative 18, and that's equal to 180. So if we solve, we get 11x is equal to 198 divided by 11. We get that x is 18. That's not what they want, though. They want PSR, which, by the way, these are the same. So it's going to be 7 times 18 minus 13. So we get that it is 113 degrees.